welcome everyone to this event called Resilient Infrastructures to Boost the Blue Economy. Thanks to all of you for being here, and I want first of all to thank all the panelists for attending and for going to make a talk. My name is Esteban Camacho. I am one of the partners of the ReSHEAlience project, which is the organizer of this event. And well, first of all, I would like to remind you that this event was initially programmed for April of 2020, but as you know, the sudden eruption of the COVID forced us to postpone it, and now, well, we decided to do the event online. But well, we remain positive, and we want to see the glass half full. Now, I guess that you can attend to this event in a different manner, drinking a cup of coffee or a cup of tea and feeling at home, because possibly you are at home. And I think that also it's an advantage that we can reach audience from different countries, from South America, from Russia, from Poland, from wherever. And I think this is an advantage, and I welcome all of you. During this event, you can propose all your questions in the chat, writing in the chat, and we will answer them in the last part, in the round table. I hope we have time to answer all the questions. And well, I will show you what is the agenda for today. We will have 5 speakers. The first will speak about policy. The second 2 speakers will speak about opportunities, problems, and challenges. And the last 2 speakers will speak about innovations in the blue economy, in the blue world. First of all, before introducing the first speaker, I would like to introduce a little bit what is the blue economy. European Union defines the blue economy as all economic activities related to oceans, seas, and coasts. It covers a wide range of interlinked and established and emerging sectors. This means that it's a very wide concept. In the document, The Blue Economy, which was published for 3rd consecutive year, the last version is from this year. The Blue Economy document published by the European Commission divides these sectors in established sectors and emerging sectors. And it accepts that now currently we have certain size of blue economy, but mainly what we have is a big potential to develop and to go beyond, which is identified and estimated. But also this concept of blue economy speaks and reminds that there is, let's say, a potential things, new opportunities and new challenges that we don't know. So these are the ideas, the things that will come and will develop in the next decades, because for sure there are still technologies and opportunities that we even didn't identify. Well, first and fast, I would like to introduce few blue potential quick fast facts to make an idea of the capacity to make economy in this sector. 70 to 80% of our planet's oxygen is produced by the ocean. Surprising, mainly marine algae. I didn't know this before starting to prepare this talk. 90% of the world's trade is carried by the sea because it is the most cost-effective. This picture was obtained yesterday in the website Marine Traffic at 9:30. It's very surprising. It's like everyone started to sail at the same time. Most of these are container ships. When I showed this to my daughter yesterday, she told me, "Wow, it's full of boats." But later, in the end, if we analyze the density of these routes, you can see that most of the ships travel through roads, and 80% of the ocean is yet unexplored. You can see there in the Antarctic Sea how almost no boat crossed ever some of these areas. So there is so much yet to explore. The sea has also a solution for a sustainable protein, because 1 kilogram of mussels has 70 times less carbon footprint than 1 kilo of beef. Maybe you didn't know that, but possibly there we can have one of the solutions to reduce the carbon footprint of our food. Offshore wind is a key for a climate neutral Europe in 2050. This is also a very interesting fact, and I guess that Mr. Ignacio Pantojo later will speak a little bit more about this technology, which has so much potential There is people doing amazing things, amazing blue things, and here you can see a few examples. For example, the sea is a promising source of research to find key drugs. 10 years ago, a novel anti-tumor agent was discovered and now it's already being sold. It's called Yondelis, and it's directly obtained from the Caribbean tunicate. Surprising. Carragelose is also an antiviral compound for respiratory diseases, obtained from the red algae. You can see the name of the brand, Marinomed. So there is a company which is specifically obtaining drugs and healthy products from the sea. Maybe the solution for the COVID is also in the sea, who knows? Artificial intelligence is used to count fishes and measure their growth. So currently, in the fish farms, it is possible to say, this week the fishes in average growth 1.2 millimeters. And soon, very soon, they will be able to track each individual fish. So they will be able to say, my favorite tuna, Dario, is growing less than last week. Which is, to me, this is amazing. I don't know exactly why this is useful, but for sure it is useful, otherwise they wouldn't have developed that. Offshore photovoltaics is already here. It is developed in Norway by the company Ocean Sun. So they have structures that can carry strong waves, storm, ice, and they are producing solar energy there. The world's largest fish farm is in Europe. It can hold 1.5 million salmons. You can see the scale of this farm. They are preparing now the second farm. You can see the scale comparing with the boat. The boat is extremely small compared to that. And this is one of my favorite. There are submarine drones under development. They are already built, and they can find what can be found by expert divers. There is a company, this company, Ocean Secrets, has optimized a drone that works really great, and they are finding sensors, machines, and things that are lost by organization or by scientific organisms. They are also using this drone to provide scientific tours. So to me, this case is especially interesting because if you develop a drone, if you optimize a drone, then you are, to me, you are very clever and hard worker. But if you optimize a drone and you build a boat and you manage to catch the tourists and show them and teach them, and you ask them for money for teaching, for learning science, then this is really an innovation in business model. And to me, this is it's like you are my hero. I want to print a poster of your company because it is really inspiring. It's inspiring, and there is people that is doing really great things in the blue growth, and I think we have a lot to learn from them. Today, you will listen many other blue developments. We will speak about them. And I want to finish reminding the words from the European Commissioner for Environment, Oceans and Fisheries. The blue economy will help us to come out from this crisis stronger, healthier, more resilient, and more sustainable. The words also from the Commissioner for Innovation, Research, Culture, Education, and Youth are: we continue to support sustainable growth in the marine and maritime sectors through the European Union Blue Growth Strategy. Research and innovation are fundamental pillars. So we have the support from the European Commission to research and to innovate in the blue economy. And I want to finish telling something that you already know, but maybe you are not aware, and is that Europe is blue. Europe is blue. We have 3 times more coastline than USA. We are blue, and we have to be more blue. So now I would like to introduce the next speaker, which is the first panelist. She is Miss Lucía Íñigo. She's Master of Science in Civil Engineering from the Universidad Politécnica de Madrid. She has experience as a research assistant in the university, and she has worked in engineering consultant companies in the Netherlands and in Spain. Since 2006, she works closely with research and development, first as research and development project manager in a Spanish construction company, and then in the public sector as officer in the International Directorate of the Spanish Innovation Agency, dealing with the EU research policy and framework programs since 2009. Ms. Lucia, welcome. The floor is yours. Thank you.
Good morning to everyone. Can you confirm you can hear me?
Yes, Lucia, we can hear you.
Perfect. Thank you very much, Esteban, for the introduction, both to the blue potential and to me. I'm the first speaker of this roundtable, and I'm going to introduce you to the opportunities for the blue economy in the Horizon programs, the research and innovation programs of the European Union. And to talk you about that, the first thing I want to share is a bit of the political context. You know, we are now under the leadership of Commissioner von der Leyen, who started last year, 2019, setting the priorities until the next mandate. These priorities have 4 main axes. You can see that there are always common things in all the commissioners and all the commission's plans, and economy is always there, and leadership of Europe in certain issues is always there. And what is new from this commission is the focus on digital, on green, and on social aspects of the transition of the future of Europe. And this is why I'm going to start talking about green, even when the theme of this workshop is blue, and Europe is blue, as Esteban told us. But one of the priorities now is green, and fortunately, green is inside this blue. So it is no problem with that, it is compatible. But what is now very important, it's or what is related to the Green Deal that von der Leyen has launched in Europe, together with all the other priorities. This European Green Deal that has been launched in this December 2019 has the main goal to Europe as a climate neutral continent in 2050, to protect human life, animals, plants, and cutting pollution, to help companies become world leaders in this green transition of green economy, and to help ensure a just and inclusive transition. And what is good about this is that we just saw in all the examples that Esteban has shown us that the blue economy has something to say in all of them, because of the potential of lowering CO2 emissions for Europe through for example, mussels as a protein, or by optimizing the trade traffic that is mainly carried out by ships or vessels in the sea. So there's a lot of things and a lot of companies working on that can be leaders about that. And that's why this Green Deal is also very important for all entities working in the blue economy. You see there that it was launched in December 2019, when we were in Europe not yet talking about the COVID crisis, which we start hearing about more in January, February, and we got hit on that in March. And there was a moment of doubt of is this going to go on, or are the priorities going to change? And the answer of the Commission was we need a recovery of this COVID crisis, and one of the focus of this recovery is going to be getting a sustainable industry and a sustainable Europe in the future, and getting companies to be leaders on that and to have a new market position on that. So that's how this Green Deal not disappear, but became even more important because it's one of the ways of investment of the European Union to recover from this COVID crisis. And this Green Deal, it's a plan with 10 actions to be followed, the 10 strategic objectives, and some of them are very relevant for the blue economy, as we are talking about supply of energy, for example, and Esteban just showed us a couple of examples of how the blue economy can help through all of the offshore ways of supplying energy, through the circular economy, and through the mobility, because of the intense trade traffic in the sea, and also about the food strategy, which is called farm to fork strategy for this new Commission. All these things are within the European Green Deal objectives and are also some of the development lines of the blue economy. And what is important about this political priority for the European programs is that all of this is going to be financed in multiple ways, and one of the ways to mobilize and to finance is through research and innovation. And that's when we start to talk about Horizon 2020 and Horizon Europe, which are the European programs that we are running currently and in the future in 2021. The first step has been to launch a new call, a new Horizon 2020 Green Deal call, which is open now. And this call has been divided in 10 areas that follow more or less the structure of the 10 objectives of the Green Deal. And there I want to highlight you the area 5, which is devoted to sustainable and smart mobility. And there's a topic in there which is open now, as I said, which talks about green airports and ports as multimodal hubs for sustainable and smart mobility. It's divided in two sub-calls or subtopics, and the second one, the area B, is devoted to green ports, and it's asking for innovation actions of between 15 and 25 million euros. So we are talking about really big projects, and it's a call of 100 million euros, which is closing in January of 2021, exactly the 26th of January. So there are now consortiums building ideas for these projects. As I said, large projects which cover a lot of developments around the sustainability and the resilience of ports. Here you have an extract of this topic that you can consult if you find it interesting for you. What I want to highlight is that it's a topic asking for large scale and high TRL, high technology readiness levels. So demonstration has to be made together with ports, with port authorities. And as it's asking for large projects, it also has to cover a set of different things. The first one, the one is shown in my slide, has to be covered by all projects, and then projects can choose to add at least 5 more of the ones that are below that one, cover a different range of things. The one that is mandatory is about low emission energy supplies and production of the port itself as an infrastructure. And then you can add things related to different aspects, many of them covering also the logistics of the functioning of the infrastructure. And as you can see in the text of the topic, it covers cross-cutting priorities like clean energy. It asks for international cooperation, as many times the logistics are dependent also on the logistics of the other ports we are working with, and of course the blue growth. And that will be the last call of Horizon 2020. which is ending in principle end of this year, but with this special code which will be ending in January of 2021. And then in the beginning of this year, we will be launching the next framework program for research and development of the European Union, which will be the Horizon Europe program, covering from 2021 to 2028. This is the 9th European RTD framework program, and its motto is to invest in the future. And the vision there of this new program has three main axes, and here we talk also a lot about green. But again, as I said before, for Horizon 2020, blue is many times embedded in this new green trend. So we were talking about targeting the climate change. The sustainable development goals are very important, and the competitiveness and growth of European companies is important too. And thinking about that, the program has been structured in 3 pillars. We have pillar 1, which is devoted to excellent science, and that, as the Commission says, it's an evolution but not a revolution of what Horizon 2020 does. So you can find there the usual calls of the European Research Council and the Maria Slodowska-Curie actions and research infrastructures that will be continued there. And if you know the program, you know that they are bottom up, so there are no thematic priorities there. But what is important is the excellence of the scientific idea, and all this the most excellent ideas and researchers that present their proposals are funded there. Then we have the pillar 2, which is devoted to the global challenges of the European Union and the European industrial competitiveness. And it's a way to join the two current pillars of industrial leadership and societal challenges of Horizon 2020. And it's divided in clusters. We have several clusters covering all of the thematic areas that have been covered in Horizon 2020, but all together here. And there will be some other initiatives relevant here, including public-private partnerships and missions that you will be able to see in the different calls of the different clusters. And then the third pillar is pillar 3, is Innovative Europe, and it's a continuation of what has been a pilot of the European Innovation Council in Horizon 2020. There again, we go to more bottom-up calls and not thematic priorities like in pillar 2, and it is more about taking the results into the market. What I want to highlight to you, talking about blue economy, are 4 of the clusters which are relevant. We have the cluster 3 devoted to civil security for society, which includes resilience of infrastructures. We have cluster 4 for digital, industry and space, covering the part of materials that has, for example, funded the ReSHEAlience project that will be under the industry part of the program. We have cluster 5 about climate, energy and mobility, and we have cluster 6 about food and bioeconomy, and all of them will have relevant calls for entities working in research and development for the blue economy. Talking about that with a little bit more of detail, in cluster 3 there will be priorities covering the resilient by design infrastructures, which is very relevant for example, for infrastructures of ports, but also all kind of offshore infrastructures. We have in cluster 4 the part of advanced materials, and then there the concept of sustainable by design will be very relevant. And sustainability, as you know, also includes resilience, because as we are making infrastructures of materials and infrastructures more resilient, we are also getting a better life cycle analysis out of that. So it's all of it is related. And we have cluster 5, which has energy, clean energy and sustainable energy, which relies a lot in offshore possibilities of energy, like the ones that are going to be presented today, offshore wind energy, or the sample of photovoltaic that Esteban named in Norway also. But also the part of mobility, which is very, very relevant. And sometimes when you see the introduction of the theme of mobility, it might seem that it only talks about electrical vehicles or e-mobility, but it's a lot wider, and it includes seas infrastructure and vessels and a lot of related research in the blue economy. And last but not least, cluster 6, which has as one of the priorities the bioeconomy strategy and the blue growth strategy, which will include a partnership named A Climate Neutral, Sustainable and Productive Blue Economy. So all of the goals of that, all of the topics will be devoted to the blue economy there. And that's all from my side. I'm looking forward to the discussion of the roundtable later and to your questions, and looking forward to hear the rest of the speakers too. Thank you very much.
Thank you very much, Ms. Lucía, Íñigo. We can see that there are many opportunities. Thank you for detailing them, because sometimes in the field of the blue economy, it's a little bit difficult to identify them because it's a very transversal topic, and there are opportunities in different fields and different goals. Okay, now we will have two speakers that will show us some of the problems, challenges, and opportunities in the coastal area. The first is Julien Mader. He's engineer in marine technologies from Institut d'Ancien de l'Ingénieur de Toulon et du Var, from France. With 20 years of experience in ADAPTI, he's currently leading the marine technologies area, coordinating development, innovation, and transfer to marine and maritime fields. For example, operational oceanography, maritime, ocean energy, fisheries, and aquaculture. He has been involved in European, national, and regional projects oriented to transfer of services and products to marine and littoral stakeholders. He is also strongly involved in the European initiatives on operational oceanography. Mr. Julien, welcome. You can take the floor. Thank you.
Do you hear me very well? I think.
Yes, we can hear you.
I think yes. So thank you, as well, saying thank you for the invitation and for this presentation. So I try to take into account all the panel to tackle some opportunities in the coastal area, but also I will let's say, some important ones to the experts we will have after me. So I work in NASTI. So, oops, the slides, yes. So as an introduction, after Esteban's presentation, I don't have to insist about the different sectors, established sectors, and also emerging sectors, but just mentioning that in this blue economy, we have also what they call enablers and supporting industries who could have a cross-link with the established and emerging sectors. So some of the opportunities also I will present are directly linked with these enablers or supporting industries where technologies like the one you are working on in ReSHEAlience could play a role. So ASTE is a technological center. So we try to transform science into solutions that respond to challenges of the sea and food value chain. So some figures to present ourselves. So we are based in the Basque Country with 3 main centers. We have almost 40 years of experience. And so we try to give solutions to all the important marine sectors related with, in particular, with the Basque economy. So to organize this presentation, so I choose to introduce a little bit, also taking some data from the already mentioned recent report from the European Commission. So I will try to complement a bit the Esteban introduction, and then I will go through some examples of opportunities, some of them related with these enablers, and in particular marine and coastal observations. So there is opportunities not only for research and development centers, but also for industry and for the private sector. Then I will give some example about how to tackle adaptation to climate change in the coastal area, some challenges related with offshore aquaculture, and I will conclude with maybe an interesting initiative that I will present, an innovation platform that could be interesting for some of you. So from this report, about in terms of established sectors, we can see that the big ones are the same always. Let's say the coastal tourism is the main one and is still growing, but offshore wind energy also is the second important one in terms of growth. So when we speak about coastal tourism, it's related with aspects related with coastal management and the big challenges we will have related with climate change to save these resources we have in the coastal area. About emerging sectors, I wanted to, so we will have more information about offshore wind energy afterwards, but I quote just this part of the report, saying directly that one of the challenges is to find most suitable materials for the floating structure. So it has been also introduced by Esteban, but there is a clear link with possible solutions proposed by projects like and companies related with the resilience topic. So this report has been made in June, so they had only preliminary data, but of course the COVID situation will have an impact in the European economy. So Lucia presented some answer from the European Commission, and in this report there is already some interesting data or analysis about the potential impact for each of these sectors and the recovery path that could be quite different depending on the sector. So sorry for the sound if you heard it. So in terms of coastal observations, we try to collect data at sea, process this data, and then to allow to put in place some services for all the sectors of the marine area. So as you can see, the climate at sea is quite harsh, so it's quite difficult to maintain some in situ platforms to acquire the data we need. So more and more we try to use also land-based platforms like these antennas that you can see. They are HF radars, giving information about environmental information. But we could have also innovations in defining in situ platforms, new types of floating structure that could include new materials to improve the efficiency and to have a cheaper maintenance for this kind of platform. So another example of opportunity related with the coastal area, all the videometry solutions. So again, Esteban gave one example related with aquaculture. In that case, it's more for the coastal management. So, and all the activities that are taking place there. So we developed based on very simple videometry hardware, but a lot of services based on the use of the information and all the digital computing solutions provided by those fields. So, and in particular related with the impacts of the storms, and as you know, in the future, those events will have more and more impact with the sea level rise. So some photos from events from 2014 in the Basque Country, we used this videometry system to monitor the run-up of the waves and the overtopping of these waves over a promenade or over a structure. So it's for adding more information in the alarm systems, but also to calibrate all the alarm systems and the information provided by the administration. So related more with structure. So an example in the port of Bermeo, we used also this videometry system to monitor the overtopping over dikes. And maybe so other related processes like huge currents in the basins in the ports produced by long waves processes. So also all the pontoons or dikes or docks structure, they could benefit from new materials because of the harsh conditions that could be stressed in this kind of events. So on climate change adaptation, so there is some figures already coming from this report about the flood damages, depending on the adaptation or not in the different countries. So there is a real need of solutions. And so we work in projects first identifying in all the sensitive areas scenarios of impact, in that case of flooding, both from the sea level rise and wave forcing. But so together with that, we need to work now on defining solutions for that. So that will be the case for anthropogenic installation like ports, but not only, also all the cities installed on the coast. And so the solution based on nature or interesting in some cases, but also maybe new materials could be very useful in some of those solutions we need to define now. In offshore aquaculture, so I put some pictures from a nice experience we had with the Prefor company. So we installed one of the first rafts made with this kind of material in the Basque Country, in the offshore marine aquaculture experimentation area led by ASTI. And so we have in ASTI and also with the company that started these offshore activities in the Basque Country, nice experience with this kind of new materials. So, and speaking on future, so there is a lot of projects trying to design the future offshore aquaculture infrastructure that could be installed offshore. So these new materials could also help to design structure that could resist hard condition at sea. So to finish this presentation, I wanted to present these initiatives led by Fraunhofer, where ASTI is involved with Tecnalia, also Technological Center in Spain. So in this consortium, we try to push an innovation platform to give some marine solutions, but transversal solutions. So in terms of technologies or new materials for some key sectors of the blue economy. So in that case, aquaculture, ocean cleaning, so related with the environmental aspect of the ocean, and energy and raw materials harvesting. So the idea is this initiative started a little bit with a research islands, but the connection with the industry will be key in this initiative. So in the future, the idea is to create some regional hubs, probably not by country, but more by sea basins, so in the Atlantic area, Mediterranean, etc. So this initiative could be interesting for other Spanish actors, both from the research part, but also for companies. And I think the network you are working with also in ReSHEAlience and in this kind of project could be interesting in being part of these initiatives for the future, trying to work together on a transversal way to tackle the next challenges. So thank you for your attention.
Thank you very much, Mr. Julian Mader. Thank you for showing so many initiatives from ASTI, which for sure is one of the big players from the blue growth sector. Well, I would like to introduce then the next speaker, Mr. Manuel Arana. Manuel Arana graduated as civil engineer at the Universidad Politécnica de Madrid. He has a master in administration of construction and real estate businesses and a master in infrastructure management and public services. He also did a management development program at the IESE Business School. Currently, he is Deputy Director of Planning and Infrastructures of Spanish Ports Authority. He is President of the Technical Association of Ports and Coasts. He is member of the Management Board of Gijón Port Authority. He is the Spanish representative in the Financial Committee of the World Association for Waterborne Transport Infrastructures. He was, in 2018 and 2019, the Spanish representative at the International Association of Marine Aids to Navigation at Lighthouse Authorities. He is representative of the Spanish ports at the Association for the Collaboration Between Ports and Cities. So, as you can see, he has a wide experience and a lot of knowledge that we are willing to enjoy. So, Mr. Manuel Arana, thank you for being here. The stage is yours.
Thank you very much. Can you see the screen and can you hear me? Everything's fine?
Yes, we can.
Oh,
thank you.
Okay, thank you very much for your presentation, and also thank you very much to the organizing committee for inviting me and Puertos del Estado to participate today in this technical online workshop. My presentation has to be seen from the point of view of the owner of an infrastructure. So I will focus on main ideas of what we need and what we expect when we design and construct a new port infrastructure. The port activity is very diverse, but unfortunately I have only 15 minutes presentation, so I have to focus on a specific topic. And the chosen topic has been the use of materials, especially concrete. Another interesting topic would have been, for example, the concept of green ports. One of our most important strategic line and a field in which we have a lot of things and a lot of ideas and a lot of experience also to share, but of course that's not possible in 15 minutes, but feel free to ask whatever you want during the round table. First of all, let me make a short presentation about Puertos del Estado, just in case somebody in the audience doesn't know who we are. Puertos del Estado is a public national agency dependent on the Ministry of Public Transport, Mobility and Urban Agenda, in charge of the general management of our national port system, 46 ports managed by 28 port authorities. Our level of activity in 2019 reached almost 565 million tons and almost 38 million passengers, including almost 11 million of cruise passengers. I have to say that we are serving the international trade, and for example, all those vessels that the chairman showed us during his introductory presentation. Obviously, this year, 2020, we are decreasing our figures due to the pandemic situation that we are unfortunately suffering. And let me show a rough figures about the evolution of our investment, just to put all these figures in context. Here you can see the evolution of our investments since 1993 during the last 27 years. In blue color, you can see the public investment. Right now, we are investing around 400 to 500 million euros a year. Our peak period was in the mid part of the last decade, around 2007, 2008, with more than 1,000 million euros every year, basically because during that period we received funds from the European Union, especially cohesion funds. The main target of our investment policy is the creation of new infrastructures such as breakwaters, quay walls, terminals, land reclamation, capital dredging, and so on. But in our port, there's also a very important investment from the private sector. Here in the figure, you can see in orange color. Right now, the relation between public and private investment is around 1:1. That means that for every public euro invest in the port, there's another private euro invest in the port. And the private sector basically invests in superstructure, in buildings, equipment, cranes, etc. So at the present time, the total investment in our port is around 800 to 1,000 million euros a year. But we expect that this investment level will increase in the years to come because construction could be a good option to recover the economic activity in the country that has been very affected by the pandemic of COVID-19. So let's talk about the main topic of this workshop, or at least what I have chosen, is the use of material in the port environment. And if we talk about materials, we must talk about durability, because we have several experiences in this field that are ruling our present policy, talking about development of the new infrastructure. Here on the slide, you can see that we are suffering some non-acceptable situation that are appearing in our infrastructure, especially at the early ages, like 8, 10, 12 years after construction, far away of the theoretical whole life cycle of the infrastructure. It's very clear, as you can see on the slide, in the crown walls of our breakwaters, for example, especially in the tidal range area and in the splash zone. But we think that corrosion situation can be also starting in unseen parts of the structure, for example, in the zones below the water level. The outside face of the structure is obviously very exposed to the environmental action, and the horizontal part are especially damaged in our experience, but also the inner part of the structure, non-desirable situation are also starting to appear. So we are especially interested in deepening our knowledge and improve the durability concept in the maritime environmental and in the maritime infrastructure, because of several reasons. The first one is obvious, that is that the maritime environment is very aggressive, but it's unfortunately the environment in which we must construct and operate our infrastructure. We have no other chance on this point. But also because our technology is generally based in massive concrete structure, especially if we talk about floating caisson solutions. This is a solution that is very typical in Spain. Most part of our infrastructure are built using this technology, floating caissons. And here on the slide, you can see a typical cross-section of a vertical breakwater using a caisson solution. The typical dimension of these kind of pieces are 50 meters long, 20 meters wide, and 25 meters tall. So we are talking about very large pieces. Normally, the total amount of steel is around 70 to 100 kilos of steel per cubic meter of concrete. So it's a hard reinforced structure. And obviously, the quality of concrete, if we're talking about concrete specifically, is one of the key points of this kind of infrastructure. And we are very interested in long-term durable solution. I will later on explain why. Especially because the typical construction method is using floating docks, and the concrete is usually submerged in just a few hours after placement. So that's a singularity of our infrastructure, because normally you read the technical papers and you say that you do not have to put the concrete in contact with seawater so early, at so early ages. More special characteristic of our infrastructure, first one, the access is very difficult. And that's important not only for repairing activities, but also for inspections. We have to know that most part of the structures are under the water, and it's difficult to access. But also the emergent part of the structure is very hard to access sometimes, but we can access only using floating elements. And normally we have to work in environments exposed to hard weather conditions such as wave, currents, winds, and so on. But there's also another reason. One of them is that normally we do not demolish all the infrastructure. That's something that is very hard to do in the usual port management activity. So we basically try to reuse all the infrastructure, and it's an important idea for our planning and construction activity. For example, here in this slide and this figure, you can see the evolution of the Port of Valencia since the 17th century. But if we focus on the last decade, and if you pay attention to the present situation, that part is 2017, you can conclude that we are basically reusing parts of the port that were built during the 20th century, 50 or 60 years ago. For example, here, if you see the situation of the Port of Valencia in mid-60s of the past century, you see here that we have a breakwater, and this breakwater right now is a quaywall. And that's very typical in our activity to reuse this infrastructure. And also, this kind of old infrastructures, 40, 50, 60 years ago, are sometimes operating under much higher loads than the design ones originally. Especially if the main purpose of the terminal is the container or the cruise market, because of the evolution of these kind of vessels in the past decade. Vessels, our main clients, have now much longer dimension than some decades ago. And there's something that we do not control, because decision of the size of the vessels are taken by board of directors in places such as Hong Kong, such as Copenhagen in Denmark, Switzerland, or wherever, but not in Puertos del Estado or not in the Port Authority's headquarters. And talking about the size of the vessel, we still don't know the limit. But what we know for sure is that the infrastructures that we are developing right now could be designed with a life cycle horizon of around 40 or 50 years, but we will be probably managed and operated and will be under service by in 70 or 80 years. And last but not least, another typical situation of the port activity is that we have difficult access to infrastructure to repair or to maintain, because what we call service first. Here you can see a couple of pictures of the container terminal in the port of Algeciras, and also a cruise vessel here operating in the port of Santa Cruz de Tenerife. And I have to say that we serve very strict markets in terms of quality, with vessels scale previously defined months or even years in advance. So we usually have short slots or short windows of time if we need to repair the structure. And for all these reasons, I think it's obviously clear that we are very interested in new technologies, new materials, focused on increasing the durability and or decreasing the needs of maintenance in the years to come. So what do we expect for the years to come? Well, one possible solution is developing new and better construction materials, especially concrete, but not only concrete. But new materials, from our point of view, must be feasible to construct, following the general principles and solution defined in the project, because very detailed and specific solution defined on the project that cannot be constructed, sometimes it happens, are not acceptable. Solution that must be constructed using floating elements are usually not easy to develop. And normally precast solution are the best option when we define very strict condition for the materials, but precast solution usually don't fit well with massive solution, as we use in maritime engineer. Mixed solution using part of regular material and part of a specific material in the most critical part of the structure could be an option. That idea would also make them useful from an economic point of view, because normally expensive material in massive solution are ideas that normally don't fit very well. What are now working? We are developing an alternative solution, an alternative materials. Here's an example. Here's the crown wall of the Escombreras breakwater in the port of Cartagena using glass fiber bars instead of steel bars in order to avoid corrosion. Here's another example of the material used for the construction of a floating caisson in the port of Puerto del Rosario in the Canary Island, in the island of Fuerteventura. It's also a kind of textile fiber. With this material, you can generate some kind of plastic panels, hard plastic panels. Here you can see the construction of the caisson, assembling different pieces. And later on, you can put it in the water using a normal crane, because the weight of this material is very light. You can transport it floating and finally sink and fill on the final position of the dolphin. Right now, this solution is in use as a dolphin for mooring cruise vessels in Fuerteventura, in the Canary. Well, I have to say that the main objective for choosing the solution in this specific case of Puerto del Rosario was probably not related with durability. In this particular case, probably the main objective of this solution was that it was not necessary to transport a floating dock to the Canary Island just to build one or two small caissons, but increasing durability is for sure an advantage of this kind of solutions. And let me please waste a couple of minutes to say a few words and introduce you one of our latest projects in Puertos del Estado. It's called the Fund Ports 4.0, with a total budget of 20 million euros until 2023. It's a program open to projects and ideas based on innovative or disruptive concepts. And one interesting target of the fund could be new materials and new construction techniques. It's not closed, it's absolutely open, but it could be an idea. Trying to upgrade the quality of the products and increasing the life cycle of the whole infrastructure. Unfortunately, I do not have time enough to explain the project. It would be very interesting, but I have only 15 minutes. But if you're interested, you can find more information on the website that you can see here on the slide, www.ports40.es. So that's in what we are working now, and we will continue on this path, talking about materials in the next year. From a general point of view, we need flexible, resilient, and green infrastructure in terms of life cycle management, in terms of change of use, adaptability to new necessities and to new loads, basically higher loads. I'm not sure if this is a wish list, impossible or very difficult to achieve, but I think that we have to move in that direction, and we are doing it as we have seen a couple of minutes ago with a couple of examples. I hope in a few years I will be able to present some successful case studies, but since then, well, thank you very much for your attention today, and you can contact me using the mail address that you can see on the screen, and of course during the round table at the end of the workshop. So thank you very much.
Thank you very much, Mr. Manuel Arana. For sure, we will visit this website because I think it's this initiative, Fund Ports 4.0, seems really interesting. Thank you also for so many useful and real examples and clear pictures. We will keep the questions for the roundtable. And now I would like to, well, we come to the third block of this event, which regards some innovations in structures for the blue economy. We have two panelists, of which the first is Professor Liberato Ferrara. He is PhD in civil engineering from the Politecnico di Milano University. He is Associate Professor of Structural Analysis and Design, and he holds the Italian national qualification to full professor. He has been Fulbright visiting scholar at the Center for Advanced Cement-Based Materials in Northwestern University, Illinois, and he is visiting professor at Beijing Yaotong University in China. He is member of the Department of Civil and Environmental Engineering in Politecnico di Milano. Professor Ferrara has dozens of publications in indexed journals, and he is currently coordinator of the H2020 project ReSHEAlience, which is the project that has organized this event. Professor Ferrara, welcome. Thank you for being here, and the floor is yours. You are muted, Professor Ferrara, if you can.
Okay, hope you can hear me now. Thanks a lot for the introduction. And as you have said, I will like to talk about this resilience project that we are now currently working on. We are in our third years. As a matter of fact, I'm starting with this picture that I took this summer in the southern Italy region where I come from. This is a sunrise on the Adriatic Sea. Just to reflect on the fact that 70% of our planet is made of water, but we call it Earth. And how much of our economy comes from the sea? We have heard from you, Esteban, that 70% of our oxygen comes from the sea. So this is the topic of blue economy. Several speakers have already talked about, and I have always also made reference to the Blue Economy Report 2020, which was published some months ago by the European Commission. As a matter of fact, in Europe, it represents about 5.4 million jobs and generates almost 500 billion euros a year. However, as you can see, the contribution to the overall economy in terms of employees or of GVA is around 2%. So there is possibility to further increase, and these are surely within the strategies that we have learned about today. And you can also see that some of the sectors in which this blue economy is divided, these are the established sectors, as we have heard, are in a quite advanced tier level, whereas some others still have a possibility to be developed. Well, this has been shown by several of you. So these are the established sectors, just to understand the variety of activities and of everyday life that we really take from the sea, from food or energy, our mobility, shipbuilding industry, our leisure time, the coastal tourism in terms of accommodation, transport, and so on. And for example, this is the marine living environment, which fits into the farm to fork Mrs. Lucia Inigo was talking about, is one of the strategies of the Commission. And you can see that Spain and Italy in this sense are the leading countries in Europe, both in terms of jobs in this sector and GVA generated. But also, as we have just heard a couple of presentations before, the growth and still the potential to growth in terms of offshore wind, because as you can see, as of now, in the 27 in short time countries of Europe, just 5 to 10% of the energy comes from offshore wind, and most of it is in the northern European countries, and largest share is actually in the UK, which no longer be part of the European Union. The trade, the sea belt trades, you can see the maritime Silk Road, but also the polar Silk Road, which will be of strategic interest of Europe. And this is related also to the picture that Esteban showed in his presentation, the traffic on the sea. And the coastal protection, this is a quite strategic sector, because we have, as Europe, 66,000 kilometers coastline, 3 times as much the one of the United States, a significant coastal defense infrastructure market. But this is also related to the climate change effect, because we can expect a severe rise of the sea level and the risk of about 700,000 European citizens to be under the risk of flooding because of this. And this is a picture which was taken 1.5 years ago in March 2019, is the Ricasoli Lighthouse on the harbor of Malta Island, so in the Mediterranean, a region where many of us expect to find warm climate throughout the year for sunbathing. Well, as a matter of fact, also this graph was also shown. Also, the blue growth sector was affected by the COVID, but as you can see, all the sectors, the established and the emerging, are ready for the recovery. So they can be a very interesting driving opportunity for the recovery, not only of the sector, but also of the European economy and of the European society as well. And also in this respect, the emerging sectors, the ocean energy, the tidal energy, but also the maritime defense, the cross-fertilization between civil sectors like the one that we have spoken so far, and defense and the security sectors can bring further opportunity to growth in this respect. So what do we need? And in this sense, I make a link with the presentation of Dr. Arana a couple of minutes before. We need, for all these activities which are related to blue economy, we need durable and resilient infrastructures. One of the huge problems is the degradation induced by the chlorides, the corrosion of the reinforcement. You can see really dramatic pictures here. And the yearly cost for the world is about 2.5 trillion of US dollars. You can easily convert into euros, which means more than 3% of the world GDP. So it only goes into solving the issues related to this problematic. We also need resilient infrastructure, because in case of extreme climate events, accidental events, weather that we are experiencing more and more frequently also because of climate change, the infrastructure, this is a raft for mussel farming, can undergo complete destruction, and this is a loss because you lose the infrastructure, but you also lose the harvest, which was on there. For the people working and living on this is a dramatic event in this case. Actually, well, I work in the field of concrete materials and concrete structural engineering, and the ReSHEAlience project worked in this field. So we work with concrete, which is a remarkably good building materials, also because it can be made with locally available constituents. So it's an ideal candidate for tailored scenario-based solutions. We all know that we produce a huge amount of concrete each year, and this also implies that we produce likewise huge amount of cement, which emits CO2 in the atmosphere. But we also need to, employ a very large amount of natural resources, for example, quarrying the aggregates. But the thing is that if you make comparative analysis, if you replace concrete with any other material, any other construction material, the carbon footprint will be higher. So simply the concrete industry, the cement industry has an impact on the environment because we use and produce a huge amount of these materials. And as a matter of fact, so this requires us to think of more performing material, which can be employed in a more sustainable and efficient way. But which performance are we asking to our concrete? This is a study which was done by Brazilian researchers, it's 10 years ago, in which is shown not only how high have we been able to go with the compressive strength of concrete, which is the primary performance that we require, but how effective have we also become in exploiting the best from each kilo of binder that we employ in terms of strength. So you can see that we really have now become very, very effective, and high strength concrete and high performance concrete really employ very few kilos of binders to achieve the unit megapascal strength as compared to ordinary or low strength concrete. But this compressive strength, the only performance that we require, or we also require when we have to go to the sea for blue economy activities to solve other issues, for example, the craneage issues. We need, when we build on the sea, much over-dimensioned cranes for lifting the weights as compared to onshore land-based cranes for the same weight. And we also have to reduce the penetration, the chloride-induced corrosion and the deterioration included by the sea, induced by the seawater, which can contain other harmful substances like magnesium sulfates as well. And also reducing the maintenance actions, because offshore construction operation can be between 5 to 10 times more expensive than offshore. So this means that we have to widen the possibility of exploiting advances in concrete technology, the possibilities of application of high performance cement-based materials. So this is the challenge in which the ReSHEAlience Consortium was built. The ReSHEAlience project started at the beginning of 2018, and we are going on until March 2022. Now we are 13 partners plus three linked third parties from 7 European countries. You can see them here in the map. And together with a group of 6 universities and research centers, we have 7 plus one partner left, industrial partners, which really cover the whole value chain of the concrete construction industry, from producers of materials, engineering and precast construction companies, and large-scale project infrastructure construction companies, and large-scale end users. So this is quite a plus of this consortium, because we could span over the whole thematic of industry. And we implemented a strategy based on 3 interacting and mutually feeding levels, which is a product innovation, a process innovation, and a context innovation. Our product innovation strategy was meant to develop ultra-high durability concrete, meant as a category of materials, but together with process innovation, which means that we are working on a durability assessment-based design methodology for structures built in extremely aggressive environment in order to really be able to predict their long-term performance. Obviously, we have some quantitative objectives, improving the performance in the uncracked state, but also improving it in the cracked state, because concrete structures do crack, increasing the resilience, at the same time reducing the cost, and having a modeling accuracy which is 75% better than what currently we can do, also with respect, especially with respect to durability performance. So in developing our ultra-high durability concrete, what we defined as stray hardening fiber of textile reinforced cementitious material, we made use of nanotechnology. We used micro and nanoscale functionalizing constituents such as alumina nanofibers, cellulose nanofibrils, or crystalline admixtures, because we want to embed nano reinforcement, self-curing properties, self-healing properties. You can see some examples of the cracks in our structures exposed to chloride-rich environment or sulfate-rich environment, able to be completely closed. And some results that we have obtained, for example, these are results obtained by our partner, University of Valencia, Universidad Politecnica. On the left, you have the chloride penetration in a regular concrete before healing. It's quite huge, the part of the concrete specimen which is penetrated by chlorides, and after healing. But you can also see with our ultra-high durability materials, we have very tiny cracks which are completely healing. So after healed, you do not have anymore the penetration of chlorides. These are results that we have obtained with reference to self-healing of the cracks and the persistence, I will say, of the mechanical performance upon continuing to submit our structure to healing and mechanical loading cycles, which is what a structure in the sea can experience. And you can see the graph on the bottom right, that with the self-healing stimulators, we can also undergo, after a few months, some improvement of the performance instead of the decay that you get without the self-healing properties. These are some results obtained by our partner, University of Ben Gurion in Israel. With textile reinforcement, you can see the cracks healed and the network of these healing products, which has also gone to improve the bond between the matrix and the textile reinforcement. And similar results have been obtained also at Technical University of Dresden, comparing also with other healing technologies. You can see the blue curves refer to a reference material under tap water or a chloride solution, and the green is the effect of alumina nanofibers and self-healing crystalline admixtures on the healing capacity of the cracks, also for quite larger cracks above 100 microns, which we can expect in some structures. And this is a summary graph which compares, you can see the blue and the green and the red dots, which show how the use of crystalline and different nanoparticles improves also the sorptivity recovery of the impermeability of the material as compared with reference material, reference UHPC. This is quite important, that we are comparing functionalized ultra-high performance concrete with reference one, which are the gray and the yellow dots. Well, as I said, we want to embed these results in terms of improved performance of the material into a durability-based design model. So we are combining the structural design algorithm with the durability degradation models in order to predict how the structural road-bearing capacity or the structure serviceability limit state indicators do evolve with time. So to be able to estimate the end of life and to perform a consistent life cycle analysis and life cycle cost study. But what we identify as the end of life of an existing structure should become a new life, because we have also tried to recycle the same materials that we have been producing. This is a study done on independent materials by Universidad Politecnica de Valencia and University of Malta, with our collaboration as well. And you can see the results from Valencia on the left. The yellow most left curve is the reference mix. But if you replace fine aggregates, coarse aggregates, or fiber with recycled materials, you have always a very, very high performance in terms of strength, even better than the reference mix. And these results were confirmed also by studies done at University of Malta, in which we also try to study the accelerated carbonation of the material. So this also gives us the perspective of recycling this material and making them fit for reuse. Actually, we are now in the pilot validation stage. We have 6 very large scale pilots, I have to say. As coordinator of the consortium, this is a matter of pride for us. 2 of them are actually in the Valencia region. One is in Valencia and one is in the Sagunto port. One of them is in Ireland, and these are strictly related to blue growth. 2 of them are in Italy and are related to renewable energies. And the 6th one is in the island of Malta, and is the retrofitting of an infrastructure in the harbor area. Was a suspended water reservoir that was severely damaged, as you can see, and we have been retrofitted. A few words and a few pictures about the pilots, which are mostly related to blue growth. This is a mussel raft made employing UHDC material. There are 10 secondary beams which are made, each one with different technology and exploring different combination of serviceability levels. It's now floating in the harbor of Valencia and is for mussel farming. And we were very happy to be able to visit it. It was February 27, I think, so just a few days before all Europe, unfortunately, went into lockdown because of the pandemic. But now the pilot is floating and it's starting feeding us the first monitoring data, which are quite interesting and has been done by our partner RDC. This is a floater for an offshore wind tower, so it's related to another topic of blue economy done by Rover Maritime together with University of Valencia. And this is a couple of days ago, the first installation into the Sagunto port nearby. And this is a floating pontoon. This is for touristic ports infrastructure, so it's related to coastal tourism. The 3 different solutions that we have been made employing ultra high durability concrete and carbon textile reinforcement. And this is the pilot floating offshore the Galway Bay in Northern Ireland, so exposed to the Northern Sea. I want just to show this picture. This is the pilot in Italy, is in a geothermal power plant, so related to renewable energies. But on the top left, you have the pictures showing the really saving of material that we can have going from ordinary concrete 10 centimeter to a precast solution with ultra high durability concrete, which is only 3 centimeters thick. So it's an amazing saving of the volume of concrete that we are employing. Well, you can follow the activities of the ReSHEAlience project on our website. We also have developed a MOOC in which all the activities summarized. You can contact me to my email at your own convenience, or follow us on the project social websites. A final reflection: this paper published by the European Commission 10 days ago, the role of advanced materials in the post-COVID area, really full of interesting concepts for us to go and look ahead, and how we can make a less dependent and more resilient European society, exploiting high performance material designed for recycling, for reshaping and remanufacturing. And on behalf of the World ReSHEAlience Project Consortium, you can see here some of us, or all of us, during our meetings, and this was our last meeting in Valencia in February. Thank you for your attention, and enjoy the rest of our workshop. Thank you very much.
Thank you very much, Professor Ferrara, for the interesting figures and these promising results from our side as RDC. You are welcome You, the audience, is welcome to visit our pilot in Valencia, the pilot in Sagunto. Now I would like to introduce the last speaker, Mr. Ignacio Pantojo, which is the Floating Offshore Wind Department Manager in Iberdrola. He is responsible for engaging the floating offshore wind sector in order to develop and provide the best floating solution for the projects to come of Iberdrola in the Scottish Power Renewable. During almost 25 years of professional experience, Ignacio has participated in more than 50 projects of industrial and power generation facilities, mainly wind farms and combined cycle power plants, urban planning, hydrology and water quality projects, and environmental modelization projects. Welcome, Mr. Ignacio. You can take the floor when you want. Thank you. I think you are muted, Ignacio.
Yes, okay. Good morning, everybody, or good afternoon already. Yes, I think you can hear me. I don't know if you can see my screen. 1 second.
Yes, we can see your screen.
Yeah, the presentation. You can see the presentation.
Yes, yes.
Okay. Okay. The issue is that when I put the presentation, I cannot see. I cannot see myself. 1 second. What's going on here? Okay. Now I think you can see me, you can hear me, and you can see the presentation. I hope so. So first, thank you very much for allowing me, for inviting me to this event. I am really delighted to be part of this new revolution of the blue energy, especially when Iberdrola decided to join in a commercial scale to this kind of projects. So I have to say that I was not really aware about who is going to be the audience. I have allowed myself to explain you a basic about the floating offshore wind projects, just to ensure that everybody will follow what we will discuss later. So in the last 15 years or even more, we have been working with bottom fixed foundation in the continental platform, mainly of Europe. And that is an exception worldwide. The rest of the world, we have not continental platforms. So very close to the shoreline, what we will have is deep water. Deep water meaning beyond 80-meter water depth. For those water depths, the bottom fix is not convenient. So at least no a commercial solution so far will be convenient for such a water depth. And we have been working during the last 10 years in understanding the physics and the dynamic below floating solutions. And 2 years ago, we decided that we have already acquired the knowledge in order to jump in the commercial status. And by commercial status, I mean that we are involved right now in some in some demonstration projects in order to test the supply chain more than to test the technical solution. Of course, we are testing the technical solution as well, but we are quite confident that the floating solution work. They will be able to bear a turbine, and the turbine will produce energy. But that is not the key. The key is to be able to make those solutions bankable, meaning economically viable, and we will be able to industrialize, meaning that we should be targeting offshore wind farm of more than 50 units as an average. But before of that, let me explain you what are the main concept that we are now testing in floating. The barge is maybe the more simple. Is a barge is a platform with certain buoyancy that is mooring and fixed to the seabed through mooring lines and anchors, and that have the capacity of supporting the turbine. Then we have the semi-submersible, that we get the buoyancy mainly by a few columns, vertical columns, and then is fixed to the seabed with the same mooring line or similar mooring line that the barge. And then we have the spar. The spar so far is the most common solution for floating, because our colleague from Equinor, the former Statoil, the Norwegian state oil company, developed this solution about 15 years ago. And the first floating project was the High Wind, and the High Wind is still on the coast of Norway, still working. Now they have changed the name because it had been bought by another company, and it's called Zephyrus. So I think it's a 2 megawatt turbine, and they have proved that this spar solution can actually work. The challenge of that solution is to export that out of Norway, because Norway have a very particular condition on the coast with very deep water in shelter area that ease or facilitate the installation of the turbine. That cannot be done in most of the rest of the location. And the last solution is the tension leg platform, where the platform itself is not self-stable in most of the concepts. So the buoyancy is not enough to keep the turbine in a still position, but we get this stability with tension leg. The advantage of that solution is that we use less material, steel or concrete, and the footprint of this solution is smaller than the other one. Another concept that we have to take into account is the cable. The cable for a floating solution is different, at least in the last flight, in the flight connecting the touching point at the seabed with the platform. The cable shall be dynamic. So the loads that that cable have to bear are higher than the load that a conventional static cable will have. And that is one of the bottleneck of becoming commercial for this kind of technology, because so far there is not still enough fabrication capacity to feed all the project to come with dynamic cables and mooring lines. So that is a general concept. Thinking about Iberdrola, you know, I guess the Spanish people in the audience, you know well Iberdrola. We are the major utility, the bigger utility in Spain, but we are a multinational company with other companies in the group, mainly in UK, Scottish Power, that is leading all the offshore development. I have been working for Scottish Power, although now I have just moved to Madrid. I am part of the team of the offshore business here in Madrid. And then we have Avangrid in the state, that is as well show their interest in developing floating projects and bottom fixed projects in the state. I think that you will be aware that we have bought, or we have a partnership with Macquarie for the pipeline in Japan, where the project will be both floating and bottom fixed. So the basic selection that we, and the important point here is that we as a company, we are completely committed with the blue and green energy. In fact, we have a lot of countries where we only produce energy using renewable technologies, but of course the projects have to be bankable. All our effort is in making those technology into an industrial scale. We have always to do an analysis of each project, taking into consideration the turbine, mainly the size of the turbine, the floating technology. In this regard, I have to remark that although we have developed our own technology, this has been for the sake of understanding the dynamic, not for owning our own patents or technology. We will always look to the market and we'll select that floating technology that will better suit to our project. Then the ocean condition, of course, will have to be taken into account, not only the wind. One of the advantages of going offshore and far offshore into the water is that we have a more steady wind and a better resource. So the capacity factor, that the percentage of hour by year that we can take for producing energy is bigger, so bigger than in bottom fixed projects that they are closer to the shore, and definitely bigger than on onshore project. Then we have to see, of course, the restriction, environmental, not only regarding the seabed, but as well the marine mammals, the birds. Socioeconomic, we have to make these projects compatible with other activities like fisheries or transport. That is really important. We need as well a grid connection point, and we analyze that. And eventually, what we do is our business case comparing the DEVEX, so meaning the investment that we have to do before starting the project, mainly is the studies of the area, the characterization of the area, the CAPEX, that is what we are going to invest in that project, and the OPEX, that will be the cost of operation. And for doing that, in the last 2 years in Iberdrola, we want to be, as we are already in bottom fix and in wind, in onshore wind, we want to be one of the major players worldwide. So we have established four work stream of work that I will explain later. Just a few remarks about Iberdrola strategy. We are technological agnostic, meaning that we are not going to be owning any technology. We have evaluated about 18 technology. We have narrowed down to those that we think that they are ready to be commercial. Those that they are still not ready to be commercial, if we think that in the future, in the near future, they will have something to say, especially in the reduction of the cost and in the industrialization of that cost, we are helping them to develop their product, but that is important. It will be their products. We want to have this technology available in the market in order to be able to choose. Okay, we are doing demonstration projects. One of the demonstration projects that I will show you later is funded by the European Commission. So we are fully aligned with the strategy of the European Commission, and we have been supported by the program H2020 that the first of the speaker make reference before. Okay, regarding the four work stream that we are developing in Iberdrola. The first one is, that is almost over, is to capacitate ourselves to do this kind of project. That means to understand the physics, the dynamic, to have the engineering capacity, and to develop all the engineering background that we need to go out to the market with a robust technical specification, and to ask the supplier, not only the technology developer of the floating platform, but all the supply chain, what we want, what we need. If we don't understand the project or the technology, we will not be able to properly ask for those solutions, and eventually we will go to a very expensive project. So that is an ongoing, always will be an ongoing work stream, but we have advanced a lot of in the last 2 years. So we have a robust knowledge of the market and the engineering. The second work stream is to develop, or to help to develop, technology that will reduce the final cost and will make these projects bankable and will be able to be industrialized, for the production of more than a single or 2 units in the demonstration projects. So in this regard, we are doing a demonstration project that is already public. That is the one that we have established in Norway, funded by the European Commission, that I will explain you later. And we have other demonstration projects that I cannot fully disclose. I will explain you some ideas later, because still they are not public, but we are working with several technologies. And the previous speaker, he has focused in a very interesting topic, that is concrete. And one of our criteria for doing demonstration projects is we want to test the concrete supply chain against the steel supply chain in order to be sure that those projects can be done in an industrial scale. Okay, the following work stream is doing taking the advantage of an ongoing bottom fix projects or some other projects that we are developing in areas that we have already all the permits and we own those projects, to take advantage of that infrastructure and to install 1 or 2 turbines on floating platform. That will be interested because we don't have the expense of the offshore substation. That is a very important expense, especially if you go to a very little amount of unit projects. So we will connect to another already existing substation owned by Iberdrola, and we will test some technical concept of floating. The disadvantage of the challenge of that work stream is that, of course, if we are connecting floating platform to an offshore substation that is serving bottom fixed projects, the water will not be very deep. It will be relatively shallow water, around 50 meters. And everybody is thinking that a floating solution should go exclusively to deep water where the bottom fixed solution cannot reach. Well, we are challenging that, and we think that there is still a few doubts or a few interrogation to answer whether floating technology can be feasible and economically viable in relatively shallow water, because although the technology is expensive than the bottom fix, but we take off from the equation a very expensive assets such as the installation of vessels, because we will install everything at the port and then we will tack away to the site location offshore the unit already assembled, meaning the floating platform plus the turbine. And the last work stream that we are ramping up now, and we are living in a very exciting times, because all this COVID situation that is a drama for most of us, but is as well a very good opportunity. There will be a lot of opportunity for getting funding or convenience economical financing condition for ramping up those projects, and we are already looking to the commercial. When I say commercial, I mean projects bigger than 200 megawatts, between 200 and 1,000 megawatts in certain areas of the world that so far I cannot disclose. Well, the first work stream in engineering, we have analyzed what I said, the main technology developer. We can divide it into barge, semi-sub, spars, and TLP. We have not done any selection so far about which one is the best. We will have to study for each of the conditions. What we can say is that the barge, the level of movement is higher, meaning that we will need more mooring lines. More mooring lines will be more expensive projects, and we will have to check whether this is suitable for certain meteor-ocean conditions. The semi-sub is after the spar, is the solution that has been more used so far. For instance, the Kincardine project, that is the biggest floating park now, is on the coast of Scotland, is using this kind of steel semi-sub solution. We are looking to semi-sub in steel and semi-sub in concrete. The spar, as I said before, the spar, the installation requirements are so demanding that they are really hard to be exported out of Norway. And then the TLP. The TLP is a tension leg platform that's they are maybe behind the other solution, the other technical concept, because they are more risky. The installation of those platform means a few challenges that they are still not completely solved, but the advantage of this platform is that the use of material, mainly steel, but we are thinking too in concrete TLP platform, is less extensive. So we will have a lighter structure, and that will reduce the cost. And one other thing that we have to take into account, the footprint, that is the distance between the anchoring points, is much more smaller than the other solution, meaning that for very deep water, in which the footprint, it could be a few kilometers for semi-sub or for barge or even for spar, here we will be talking about just a few hundred of meters or even less, reducing the impact on the seabed and the cost of the mooring system. That is just an example. I don't want to point any of these potential technologies to be used in any commercial wind farm, but of course, I guess the people know the PPI solution, the principal power solution. That is an American company with one of the better known design. It's a semi-sub in steel, and that is the one that is used in Kincardine project. Another semi-sub is Naval Energy Solution. It's a quite robust design based in 3 columns for giving the buoyancy, and with a center column for the turbine location. While the PPI solution, the turbine is in one of the corners. That have several advantages and as well some disadvantages. And another semi-sub, in this case in concrete, is the Olaf-Olsen solution. That is one of the technology that we are testing in our demonstration projects. It's very alike to, the concept is very like to Naval Energy or to Nautilus, but these two are in steel, this one are in concrete. Then, as an example of barge, the better known is Ideol, is a French technology that they have done several demonstration projects in France and Japan, and we are looking to this solution. And then we have what we call a more original or breaking through solution. One is the Stisdal solution that is looking at how to simplify the design in order to minimize the fabrication requirement, and they have produced a very slender design that they are going to test in Norway, very close to where we are testing the Olaf-Olsen solution. And another Spanish example is the barge by Saitec that they use, first as you know, is the only technology that they use pre-tense concrete, and they have already started the testing of their solution first in a scale 1 to 6 in the north of Spain, and the next year I think they will start the fabrication of the full scale for 2 megawatt turbine.
Mr. Ignacio,
yeah.
If you can summarize, you have 1 or 2 minutes more.
Yeah.
Thank
okay. I just want to show you the flagship project. That is the project that we have already launched, that is public in Norway. And this project have the support of the European Commission, and we have the commitment of install a turbine bigger than 10 megawatt on semi-sub concrete technology. This technology is developed, is designed by Olaf-Olsen. We have a consortium of 12 partners, and our target is not only to test one turbine, but to extrapolate to what we call a supper site, where we will check how will be the fabrication, the manufacturing of a wind farm of 50 units, in order to check if it's possible to achieve our target of around 50 euros per megawatt hour in 2030. That is another of the potential demonstration projects that we want to test. The concepts are very similar, but with steel. And what we want is to develop to help to develop a very strong supply chain for this solution in steel in the north of Spain, or in Spain in general. And the idea is to manufacture in the north of Spain and then to tag away till Canary Island and testing there during 2 years the performance of the unit, the asset, in the Plocan facilities at the Canary Island. As I said before, we are as well taking advantage of the project that they are already going on with a bottom fixed solution, where we are studying the feasibility of installing a floating solution in shallow water. We already have done the pre-engineering works. The project has been delayed slightly, but we are about to launch the call for tender for selecting the floating solution that we will install there if we get the final investment decision for this project. Of course, I guess everybody is aware that the Scottish government has launched the ScotWind round, where at least half of the areas will be for floating, and we are preparing our offer for these projects that will be commercial full-scale projects. We have as well doing the same exercise for France, where the project in Brittany will be floating, and we are analyzing as well our opportunities of doing floating projects in the state. And that has been my presentation. I really thank the organizer to give me the opportunity of explaining what we are doing in Iberdrola. And if anyone need or want to contact me, here you have an email. I will not commit to answer you immediately because we are in a quite busy times, but I will try to answer all you. Thank you very much.
Thank you very much, Mr. Pantojo, for showing this the impressive potential of Iberdrola. I like especially this sentence, we are technology agnostic. It means that you are not loyal to any current solution, but you are open to turn innovations into reality. Well, I would like to tell me, please.
I think that they are complementary. We have to look to most the technology that we think it will be something to say, but it doesn't mean that once we have analyzed the technology and we think that is a good technology, we will have to marry to that technology. We will analyze each opportunity for each project.
Perfect. Thank you very much. With this, we have finished this very interesting presentation. Thank you for complying with the time frame. Now I would like to invite you to open the discussion to a round table where all the speakers will can proceed with the camera. And I will also propose some of the questions from the audience. We have many of them. The first one, if I may launch it, is for Manuel Arana. A person is asking, would you say that improved durability to corrosion is the most relevant target for new innovative materials used in ports, or there are other relevant targets?
I don't know. I don't know if it's the gold medal problem, but it's probably a metal problem. It's one of our most important problem because we have several bad experience with durability. Not only increasing the durability or the life cycle of the materials, but also, for example, we have also problems with the strength of the material. That is related, but it's not the same thing, but it's obviously related. And the reason is because, as I explained during my presentation, loads and charges are continuously increasing. We do not manage this increase of loads because it's in the hands of our clients, and we just must solve that solution. And why? Because if you do not service your clients, they're going to move to another port, and that's not acceptable for us. So we try to make best service as we can, and obviously durability is one of our main goals.
Perfect, thank you. I am going to launch this question for all the panelists. A person is asking, do you consider that investing in a structure with an everlasting material is always the best option? Is it considered the recycling of this type of materials? If anyone wants to answer. Investing in a structure with an everlasting material, is it always the best option for blue economy? Maybe Professor Ferrara, maybe.
Well, he posed the question, but I think that we have to find a good balance between both options. So we need to extend the service life, but be ready since from the beginning to give a new life to the material, to the structure, and so on. I was quite intrigued by the maps that Manuel Arana showed about the port of Valencia, how the increase of the infrastructure incorporated the different pre-existing, dating back from some centuries ago, the pre-existing infrastructure. So I think that that is truly the key in which we can think that, okay, and as Manuel was saying, you have the infrastructure, but we expect higher loads, and you don't know how this load will evolve. So you have to be ready to have this everlasting structure in the beginning, but also be ready at the same time to rapidly recycle and remanufacture it to comply with that. It's something that it's a challenge, I understand, because in different sectors there are different inertias to this kind of thing, but probably we have to find a good combination between longer service life, but also a concept which from the beginning is ready to redesigning, reusing material, reshaping and remanufacturing. This is probably what we have to be used to. And I also speak from an educator perspective. So we have to start teaching our future engineers that this is probably the way they have to be ready to go.
Well, I think it's a different perspective from the point of view of a civil work or infrastructure than from the point of view of mechanical facilities that will produce energy. So although we can design and manufacture a concrete structure, floating concrete structure that will last more than 200 years, the turbine will only last 25 years. And the reason for that is because a mechanical asset where a lot of movement, frictions, and loads and fatigue, it will be extremely expensive to manufacture for lasting more than 25 years. And it will be at the end not economically viable because the technology evolves, and most likely that technology will be superseded by other before the life cycle. But it doesn't mean that we are going just to decommission and to trash what we have installed after 25 years. But it's really, really hard. I think it's almost technically impossible to design a bottom fish structure for lasting more than the life of the turbine, because we will not be able to repower that structure. The structure is designed for holding that particular turbine with particular loads and conditions, and the same for concrete floating or for steel concrete structure. What we are doing is to consider the evolution of the environmental condition. Now that the climate change is a fact, although there are still people discussing about that, but it's a fact, we are realizing that the historical data that we use for design our structure, they are losing their validity, and we are going to have more extreme events during the life cycle of our asset. So although we still design according to this information, we make some modeling in order to check what will be the performance or the behavior of our structure, considering several scenarios in which the historical set of data from Meteocean condition will change. That's in one side. And in the other side, of course, we look at the recyclability of our solution. Whatever we install in the sea, on the seabed, we have to present a decommissioning plan in order to leave the environment in almost the same condition that we had found before doing the project and operating the project during 25 years. But to use everlasting material, I am not an expert here. We have the Professor Ferrara and people that they are civil engineers. I think it's not economically viable, at least in the projects that I am involved in.
Thank you very much. I think I can connect this answer with another question, which is very related, which states, possibly there is an uncertainty caused by the climate change in the blue sector. If yes, is this slowing down the growth compared with the prospects? For example, Julian, I think you have experience with different devices, and you have mentioned the influence of your studies of the environment. Do you think that this uncertainty is having an effect in the development of the blue economy, in the investments?
I think generally speaking, climate change is more an opportunity for the blue sector in general. And speaking about uncertainties, as mentioned before, we started having some information about what we will have, and so very few people didn't recognize that there is a clear trend. So that's true that, for example, it's much more difficult to predict the number of extreme events that we will have in 100 years. It's more difficult than predicting the sea level, the mean sea level, for example. So there is some needs to know more about the condition in the future, but we have information, and so what we need to do is to design our infrastructure to be prepared for these conditions. So, and generally speaking, I think, and as presented in all the presentation and in what Europe is trying to promote, there is a lot of opportunities associated to climate change.
Thank you. We have another interesting question. Can you mention innovations in the blue economy that can contribute to the European Union climate neutral priority? Maybe in the field of the offshore floating farms, or maybe Julien.
I'm not sure if I have understood the question, because there is a little noise, at least in my side. But if you have asked about our contribution to the future net zero CO2 policy, of course, if we use renewable energy, even taking into account the whole cycle, I am not going to be unrealistic to say that we will not produce any CO2 emission. We will produce during the fabrication process. But if we put together the wind energy that we produce in a floating, and we combine with hydrogen, and this hydrogen can power the facilities for manufacturing, or even the vessel that we use for the operation and maintenance, so the reduction of CO2 is dramatic. In that case, yes, of course, we contribute to that.
We have a question that could be also answered by you or by any other of the panelists. What are the limitations for concrete to be considered in offshore infrastructures? This is especially relevant for our audience because I think they are mainly from the concrete world, and sometimes, at least I have heard this question: why concrete or high performance concrete or ultra high performance concrete is not so much used in offshore structures?
Well, I can start giving my perspective in a sense. Well, if you go for ultra high materials, which could be ideal candidates for offshore, because you can have lighter structure, you have higher durability, you have several advantages. Well, there may be several reasons, and actually, I think that we are all concurrently working to solve these drawbacks. For sure, any new material in the civil engineering field, in the construction field, needs quite a long time to be fully accepted, because you have the problem of design standards, and those take time to come out, to be accepted, to be validated. You need time to spread the confidence in the users. So it's a matter which involves different sectors, the authorities, universities, things like that. Other thing is that when you start with the new material, there is always the thing that these new materials, they come out like patented, they look like luxury products. So we have to work out to break this concept, because if you want to spread the use of a material, you must be able to do it everywhere. And concrete, the beauty of concrete is that you can make with local materials too. This is something that really has to go. And this is also difficult because it looks like that we are going towards like a composition or prescription approach, whereas we have to always look at the performance. So this is, but this is something that, well, I'm not speaking only of our project, but all the communities, universities, contractors, and so are really working towards. I think that construction industry is like a quite inertial sector. So implementing new things into that because of several reasons may not be as easy as in high-tech world or things like that.
Someone is asking here, Mr. Ignacio, if some of the offshore solutions that you presented could be feasible for smaller seas, such as the Mediterranean Sea.
Yes, yes. In fact, one of the objective of our project in Norway, although we are going to test during 2 years the solution at the Norway on the Norway coast, so more or less North Sea conditions, we are going to extrapolate and we will do modeling comparing what we will have to do to the modification that we really expect that will not be very significant for relocating that solution or using that solution in all the sea that we have an interest in, meaning Atlantic in Europe and the State, Pacific, Mediterranean, and North Sea. Of course they are. So, and the next, the first floating project in Europe, in the Mediterranean Sea, it's that's going according to plan. We will be able to see in 1 year in front of Marseille. It will not be done by Iberdrola, but it will be using a technology that we are working with. So yes, the Mediterranean Sea, of course, we will have floating projects in the near future.
Perfect. This question is for Lucia. We received here something. Someone is writing. You explained several opportunities, so different goals that could be related with the blue economy. Are there specific goals where the companies and the small and medium enterprises could have a chance?
Yes, all of those calls will be open for consortia, which are usually very wide and include SMEs that are developing those solutions and taking them to the market. And then in addition, you have the third pillar, which is devoted to innovation, and there you will find specific instruments like the EIC Accelerator, the European Innovation Council Accelerator, which is an instrument only for SMEs that are taking the solutions to the market once they have been developed. So we have there are things that probably have been developed earlier by themselves or together in a consortium of projects. And then to take this innovation to the market, you will have specific instruments devoted to SMEs for that.
Thank you. And the last question, I want to launch it to Manuel Arana. This is my question. I decided to make it. It's not from the audience. But I would like to ask a little bit more about this. This initiative funds Ports 4.0. If there is a chance to test innovative materials, new materials, to test them in docks, in ports, in infrastructures, and to what extent? Is it real environment, TRL6, TRL7?
Well, the fund Ports 4.0 is a brand new initiative of Puertos del Estado. It was launched, I think, in April or in May, perhaps. And I think the deadline for the proposal of ideas or project finished, I think, last week, unfortunately, last week, September 28 or something like that. But it's open to any idea or any project related to port activity, logistics, green initiative related to transport. It's absolutely open. So we have the first budget for this Ports 4.0 is 20 million up to 2023. But I think if it's a successful experience, and I hope it will be, we will launch new tenders in the years to come, because it's a strategic line of the national port system. It has been approved by the minister, and I think that I think Puertos del Estado and the whole port authorities think that it's that it's a strategic line for us, so we are going to bet for this idea. And one interesting option is that if we are able to earn any money from I don't know, from developing ideas, we can reuse this money to finance new projects in the years to come. So it's our first. It's the first time that we are going to launch this initiative, but I'm sure that it's not going to be the last one. And it's completely open, also for new materials.
To me, it sounds great that it's an open program, because this is what a small and medium company needs: flexibility to introduce new ideas and disruptive concepts. Thank you very much.
We want to be very flexible. We want to be very flexible. And also very generous with the ideas, with the good ideas.
This sounds good. Thank you very much. It's 1:30. I think we exceeded already our timetable, but I think it has been very nice, because all of you are experts in different fields of the blue growth, and combining these ideas, I think all the talks provided very relevant ideas and knowledge. To my view, it has been very helpful and very efficient talk, very efficient event. Thank you for all the panelists, for all of you. Thank you for your time. Thanks to all the assistants, and I hope that we have the chance in a year or 2 years to repeat this similar event. Thank you very much, and have a nice day.
It's been a pleasure. Thank you.
You're welcome. Thank you.
Thank you.